Welcome to Physics Unwrapped YouTube channel. In today's video, I am going to solve questions based on differential equations which was asked in the previous year question papers of physical science. I am going to solve the questions of a differential equations from 2013 to 2025, that is present. Yes, let us start with the first question. The first question says the equation, that is d square z divided by dx square minus 2 times of x dz divided by dx plus 2 times of lambda into z, which is equal to 0, is called, this was asked in the year 2013. It is called the Legendre equations, Bessel's equation, Hermite equations, and Beltram's equation. So if I look at this equation, the general equation I can write in terms of d square y divided by dx square minus 2 times of x dy divided by dx plus 2 times of n into z, which is equal to 0. So this is a particular equation for Hermite equation. The given equation is similar to this, and only the change in the variable, that is instead of z, instead of y, they have kept it to be z, and instead of n, they have kept it to be lambda. So this is the equation for Hermite equation. Okay, and here n is a positive integer. Instead of lambda, we have a n, or instead of n, we have a lambda. So it's a direct question, just little twist was there. It's a Hermite equation. Okay, now yes, let us move on to the next question. The next question is, which was asked in 2015. The question says the independent solution of the following equation, that is d square y divided by dx square minus 3 times of dy divided by dx plus 2 times of y, which is equal to 0, or. So independent solution, first I am going to rewrite this equation, that is d square y divided by dx square minus 3 times of dy by dx plus 2 times of y, which is equal to 0, right? Now what I need to do means, I need to solve this equation. How to solve this equation? So I can write the auxiliary equation of the following equation. What does the auxiliary equation tells means, instead of d square y divided by dx square, I am writing as m square, where m is a root of the equation, minus 3 times of m plus 2, which is equal to 0. Okay, this is my auxiliary equation from the given equation. Now this, it is converted into the quadratic equation, right? We can solve the quadratic equation. We will get the roots of the quadratic equation, then substitute in the complementary function. The roots we are going to get, no, that will be the independent solutions of the following equations. Now I am going to solve this. It will be 2 times of m square. So 2 times of m square, in the middle we have minus of 3 times of m. It will be 1 2 is 2, 1m, 2m, minus minus, so it will be minus 3m, right? So on substituting, instead of minus 3m minus m minus 2m, it will be one and the same, m square minus m minus 2m plus 2, that is equal to 0. Okay, taking m common, it will be m minus 1. In this two terms, taking minus 2 common, it will be m minus 1, right? Now m minus 1 I am going to take common, remaining is m minus 2. So m value will be 1 and m value will be 2. I am calling this to be m1, I am calling this to be m2. Okay, these are the roots of this given equation. Now complementary function. Okay, the complementary function can be written as, if the two roots are real and distinct, so I can write it as c1 into e to the power of m1x plus c2 into e to the power of m2 into x. Okay, where m1x and m2x, m1 m2 are the, what we call it as the roots. Okay, and your x is a variable. Here is exponent of m1x plus e to the power of, that is exponent of m2 into x, exponential. The c1 and c2 are the constants here. Okay, now replace instead of m1 to be equal to 1, instead of m2 to be equal to 2. Okay, so here it will be complementary function. The solution will be c1 into e to the power of x plus c2 into e to the power of 2x. Okay, now e to the power of x, e to the power of 2x are the independent solutions of this equation. Okay, so which option is right? Option B is the right option. Okay, yes, I hope everyone is clear. First, what we did, we took the equation and we have written the auxiliary equation. We have solved the quadratic equation. Yes, now on solving the quadratic equation, we got the roots to be 1 and 2. We have substituted in a complementary function, that is e to the power of m1x and e to the power of m2x will be the independent solution of the following equation. Okay, yes, let us proceed to the next question. What does the next question says? The general solution of d square y divided by dx square plus omega square y, which is equal to 0. What is the general solution, which was asked in 2016? Let me write the equation, that is d square y divided by dx square plus omega square y, which is equal to 0. Again writing the auxiliary equation. Now the auxiliary equation will be m square plus omega square, which is equal to 0. On rearranging the terms, it will be m square, which is equal to minus of omega square, taking square root m, which is equal to plus or minus square root of minus omega square, right? So square root get cancelled, it will be plus or minus, and square will be present for minus 1. So square root of minus 1 is I into omega. Okay, so we got the m value to be plus or minus I into omega, right? So these are the roots of the equation, that is m1, which is equal to plus I omega, and m2, which is equal to minus I omega. Now the general solution in the for the given equation is nothing but the complementary function. The complementary function for the imaginary roots, that is alpha plus I into beta, right? Imaginary roots, instead of alpha, here we have a 0. On comparing both the equation, instead of alpha we have a 0, and instead of beta we have a omega, right? The complementary function for the imaginary roots will be, that is e to the power of alpha into x into a into cos of beta into x plus b into sine of beta into x. Okay, this is a solution, that is a complementary function where the roots to be imaginary. Okay, now instead of alpha, what we have? Instead of alpha we have 0, so e to the power of 0 into x. A and b are the constants here. I'm going to keep as it is, a into cos of beta into x. Instead of beta we have a omega, so cos of omega into x plus b into sine of omega into x. So e to the power of 0, it is obviously 1. So the complementary function or the general solution will be a into cos of omega x plus b into sine of omega x. Okay, now instead of a and b, we have in the options, that is c and d. Here a and b and c and d are one and the same, they are the constants. So I'm going with the option C, and option C is the right answer. Yes, let us proceed to the next question. The next question says here the solution of the differential equation. They have given the differential equation. We need to find the solution, which was asked in 2017. Okay, now this is the equation. This can be solved by variable separable method. Okay, now I'm going to rewrite the equation, that is dy by dx, which is equal to minus of y square divided by x square. Okay, on rearranging the terms, I'm going to get dy divided by y square, which is equal to minus of dx divided by x square. Now, keeping this denominator to the numerator, the powers will be, if it is plus, it will be minus. Okay. So, it will be y minus 2 dy, which is equal to minus of x minus 2 into dx. Okay. Now, on integration, what we get, do the integration of this. Okay. If I do integration, y to the power of minus 2 plus 1 divided by minus 2 plus 1, which is equal to minus of x to the power of minus 2 plus 1 divided by minus 2 plus 1 and plus constant. Okay. Now, after integration, the constant will exist. Now, y to the power of minus 2 plus 1, which will be equal to y to the power of minus 1 divided by minus 1, that is equal to minus y to the power of minus 2 plus 1, it will be minus 1 divided by minus 2 plus 1, it will be minus 1, minus of minus, it will be plus. Okay, plus c. Now I'm going to continue here. Now, y to the power of minus 1 can be written as minus of 1 divided by y, because in the numerator I have minus, which is equal to 1 divided by x plus constant c, or I can write it as 1 divided by x. If I take 1 divided by y to my right hand side, it will be plus 1 divided by y, that is equal to constant. A constant can be a negative or a positive, so it will not matter. Okay, now the solution is 1 divided by x plus 1 divided by y, which is equal to 0. The solution is option D is the right option. Yes. Now let us move on to the next question. That is, the next question is a solution of the differential equation, that is it which was asked in the 2018, that is dy divided by dx, which is equal to minus of y cube divided by x to the power 4, which was very similar question which was asked in 2017. Let us try to solve this question. That is dy divided by dx, which is equal to minus y cube divided by x to the power of 4. On rearranging, this is also by the same method, that is a variable separable method. Okay, on rearranging the terms, I got dy divided by y cube, which is equal to minus of dx divided by x to the power of 4. Okay, now if I keep this to the numerator, it will be y to the power of minus 3 dy, which is equal to minus of x to the power of minus 4 into dx. Okay, now on integration, what we get, y to the power of minus 3 plus 1 divided by minus 3 plus 1, that is equal to negative of x to the power of minus 4 plus 1 divided by minus 4 plus 1. Now on rearranging, it will be y to the power of minus 2 divided by minus 2, that is equal to minus of x to the power of minus 3 divided by minus 4 plus 1, it will be minus 3. Okay, I'm going to continue here. So on rearranging, it will be minus of minus, it will be plus y to the power of minus 2 divided by minus 2, that is equal to x to the power of minus 3 divided by 3. Okay, now it will be, just do the cross multiply and solve. It is y to the power of minus 2 divided by minus 2, which is equal to x to the power of minus 3 divided by minus 3. Just do the cross multiplication of these numbers, then we are going to get the answer. I'm matching with the options. This is the end of the solution. I'm going to matching with the options, that is 3 times of y to the power of minus 2, which is equal to minus 2 times of x to the power of minus 3, and this is 3 divided by y square, which is equal to minus 2 divided by x to the power of 3. Keeping this to LHS side, 3 divided by y square plus 2 divided by x cube, that is equal to constant. That is, after integration we get a constant. So which is the correct option? Option D is the right option. Yes, I hope this question is very clear to everyone. Let us proceed to the next question. Yes, what is the next question? The next question here is the two independent solution of the following differential equations. So the differential equations, this is the same which was asked in 2015, I guess, the similar question. Now I'm going to rewrite the equation, that is d square y divided by dx square plus 3 times of dy by dx plus 2 times of y, which is equal to 0. Writing the auxiliary equation, I'm getting the auxiliary equation to be equal to m square plus 3 times of m plus 2, which is equal to 0. Now solving this quadratic equations, it will be 2 times of m square, 1 2s are, it will be plus 1 plus 2 m. Now replacing instead of 3m to be m and 2m, so it will be m square plus m plus 2m plus 2, which is equal to 0. On rearranging the terms, I'm going to get m into m plus 1, that I'm going to take the common, and in this also I'm going to take that common, that is 2 to be common, that is m plus 1, which is equal to 0. Again taking the common, m plus 1, so it will be m plus 1, remaining is m plus 2, which is equal to 0. On equating it to the 0, we got the roots to be equal to m, which is equal to minus 1, and m, which is equal to minus 2. These are the roots. I'm calling it as m1 and m2. The roots are real and distinct. We have a solution, that is y, the complementary equation or the complementary function or the solution, general solution, you can call anything. So y, which is equal to c1 e to the power of m1 into x and c2 e to the power of m2 into x. So c1 and c2 are the constant, e to the power of m1, that is minus x, plus c2 e to the power of m2 minus 2 into x. So e to the power of minus x, e to the power of minus 2x, e to the power of minus x, e to the power of minus 2x. That is option A, or the two independent solutions of the following differential equations. So the similar pattern of the questions they are asking, and differential equations is a quite easy topic, and they have asked less when compared to the matrices, you can see, right? Yeah, now we have the next question, which was asked recently in the year 2025. Yes, now let us solve this question. The question is the orthogonality condition for Hn of x. Hn of x is a Hermite polynomials they have given here, and related to Hermite polynomial, we have solved the first question, which was asked in 2013. Now the orthogonality condition for the Hermite polynomial, I have written the equation for the Hermite polynomial, right? For that also we have a similar direct orthogonality condition. That orthogonality condition is a first option. This is the direct question. Nothing changed. Orthogonality condition, it is nothing for our Hermite polynomial. It is nothing but minus infinity to the plus infinity e to the power of minus x square hm of x hn of x into dx, which is equal to 2 to the power of n square root of pi n factorial deduct delta mn. So this is the orthogonality condition for a Hermite polynomial. Yes, I hope everyone is clear with this video. Thank you for watching. For more videos, you can visit my YouTube channel.